Hey, good timing. Today's video on Edge and Connectivity, Route 53, CloudFront, Global Accelerator, Direct Connect, VPN connects dots from the last few lessons into one clean picture. Let's go. By the end of this video, you'll know exactly which Amazon Web Services Edge service to reach for when global users start hitting your app, and which connectivity option to pick when an office needs a secure pipe into Amazon Web Services. Here's the situation. You've deployed a workload in Amazon Web Services, and now two real problems land at once. Users all over the world need fast responses, and your on-premises office needs a reliable, secure connection in. 5 services answer these two scenarios, and they overlap just enough to look like substitutes when they actually solve different parts of the problem. We'll cover Route 53, CloudFront, Global Accelerator, Direct Connect, and site-to-site VPN, and the decision rules that separate them cleanly. In the last episode, we built out the virtual private cloud, subnets, the NAT gateway, the Internet gateway, and VPC endpoints. That covered how traffic moves inside one VPC and how it gets in and out. But a workload sitting in a VPC still leaves two scenarios wide open. How do users scattered across the globe reach it quickly? And how does the client's on-premises office connect into it? That's what this episode is about. Let's lock in 5 terms before we go deeper. Route 53 is Amazon Web Services' global DNS service. It translates domain names into addresses and decides which endpoint a request even goes to. CloudFront is the content delivery network that caches web content close to your users. Global Accelerator gives you static IP addresses and routes traffic over the Amazon Web Services backbone to the nearest healthy endpoint. Direct Connect is a private, dedicated fiber link from your data center into Amazon Web Services, and site-to-site VPN is an encrypted tunnel from your office to your VPC over the public internet. 3 handle inbound users. 2 connect on-premises to Amazon Web Services. Picture a code gorillas client whose workload is finally running inside a VPC. The infrastructure is up. The database is healthy. Everything works. But the moment real users show up, 2 new problems land on the table. First, how do you get fast responses to users in Tokyo, London, and Sao Paulo all at once? And second, the client's headquarters office needs a reliable pipe into Amazon Web Services. How do you build that? 5 services answer these 2 scenarios, and each one solves a different part of that problem. Here's the whole landscape on one slide. On the left are the 3 services that handle inbound traffic from global users. Route 53 does DNS routing. It picks which endpoint a request goes to. CloudFront caches content near the user, and Global Accelerator optimizes the network path for traffic that can't be cached. On the right are the 2 services that connect an on-premises office into Amazon Web Services. Direct Connect runs a private fiber line, and site-to-site VPN runs an encrypted tunnel over the internet. 2 jobs, 5 services. Keep this split in your head and the rest of the episode falls into place. Let's start with Route 53, because it's the front door of almost every Amazon Web Services architecture. Before CloudFront caches anything, before Global Accelerator routes anything, before a load balancer even sees the request, Route 53 has already made a decision. Which endpoint does this user's request go to in the first place? It's DNS. And DNS is the very first step in resolving any web request. That position makes it more powerful than people expect. At its core, Route 53 is a global, highly available managed DNS service. It translates domain names into IP addresses. When someone types your domain, Route 53 answers with where to go. It also registers domains for you and runs built-in health checks, which we'll come back to. Like IAM and CloudFront, it's a global service. You create it once and it works everywhere, not per region. And here's a small fact that sticks. The name comes from port 53. The standard port DNS has always run on. The real power of Route 53 lives in its routing policies. As the Route 53 Developer Guide puts it, when you create a record, you choose a routing policy, which determines how Route 53 responds to queries. In other words, the policy is the brain. It's the rule that decides which answer a user gets back when they ask for your domain. There are 8 of these policies, and the skill is matching a scenario to the right one. Think of Route 53 as a smart receptionist fielding incoming calls. A simple policy just hands every caller the same number. A weighted policy sends 10% of callers to the new office for a trial run. A latency policy connects you to the nearest branch. A failover policy routes you to the backup line when the main line goes down. And a geolocation policy sends French callers straight to the Paris desk. Each policy is just a different rule the receptionist follows. Let's lay them all out. Here are the 8, grouped 2 ways. The behavior-based ones first. Simple sends everyone to one resource with no logic. Weighted splits traffic by percentage, perfect for A/B testing or a gradual rollout. Latency routes each user to the lowest latency region. And failover gives you active-passive disaster recovery. Now the location and client, IP, ones. Geolocation routes by the user's actual country or continent. Geoproximity routes by geographic distance to your resources. And crucially, it lets you bias traffic toward or away from a location. IP-based routing, added in 2022, lets you route on the client's source IP, matching their originating CIDR block to a destination you choose. And Multivalue returns up to 8 healthy records at random. Underneath all of this, health checks are what make Failover and Multivalue genuinely reliable. Here's how to map a scenario to a policy fast. When the question says gradual rollout or A/B test, that's weighted. When it says fastest region or lowest latency, that's latency routing. Active-passive disaster recovery is failover. Route European users to European endpoints, that's geolocation, routing by where the user is. Now there's one distinction that's easy to miss. If the wording mentions adjustable bias or shifting a portion of traffic toward a location, that's geoproximity, not geolocation. The bias and traffic shift language is the tell, geolocation routes by the user's country, while geoproximity routes by distance and lets you tune it. Multivalue is the one people misread, so here it is straight from the Route 53 Developer Guide. Use multi-value answer routing when you want Route 53 to respond to queries with up to 8 healthy records selected at random. The key words there are healthy and at random. It's not a load balancer, it's a simple way to spread requests across several endpoints while quietly dropping any that fail their health check. That last part is what makes it reliable, and it's a perfect bridge to why health checks matter so much. Here's a detail worth pinning down. Failover routing only works if it knows the primary is actually down, and that knowledge comes from health checks. Without them, Route 53 has no idea your primary endpoint died, so it keeps cheerfully handing users a dead address. Health checks are the monitors that test an endpoint, and let Route 53 stop returning records that point to something unhealthy. That's what makes automatic DNS failover real. So if a scenario asks for highly available failover, health checks aren't optional, they're the mechanism. Now that Route 53 has pointed the user at the right place, let's make that place fast. CloudFront is Amazon Web Services' global content delivery network, with more than 750 edge locations spread around the world. Its job is to cache HTTP and HTTPS content close to your users, which cuts latency for them and takes load off your origin. The origin, where the real content lives, can be an S3 bucket, an application load balancer, an EC2 instance, or any custom HTTP origin you pointed at. Whatever the source, CloudFront serves it from whichever edge location is nearest to the user. The simplest way to picture this is a chain of corner stores. Your origin is the central warehouse, far away, and slow to reach if everyone has to drive there. CloudFront is the network of corner stores that stock the popular items. Instead of every customer driving across town to the warehouse, they just grab the milk from the store down the street. That's caching at the edge. The popular content sits close to the people who want it, so the trip is short. Let's trace a single request. A user in Tokyo asks for an image. Their request goes to the nearest CloudFront edge location, not all the way back to your origin. If that edge already has the image cached, a cache hit, it returns instantly, and the origin never even hears about it. Only on a cache miss, the first time the content is requested at that edge, does CloudFront reach back to the origin, whether that's S3, an ALB, or EC2. It fetches the content once, caches it, and every subsequent Tokyo user gets the fast local copy. That's how CloudFront cuts both latency and origin load at the same time. CloudFront isn't only about speed, it's also a security layer. It integrates with Amazon Web Services WAF, the web application firewall we covered earlier in the course, to filter malicious HTTP requests like SQL injection right at the edge before they ever reach your origin. It also works with Amazon Web Services Shield for DDoS protection, and Shield standard is automatic and free on every account. On top of that, CloudFront adds HTTPS and field-level encryption for sensitive data, so when a scenario asks how to protect a global web app at the edge, the answer pairs CloudFront with WAF and Shield. Now here's the service that gets confused with CloudFront the most: Global Accelerator. It gives you two static IP addresses that act as a single fixed entry point to your application. From there, it routes TCP and UDP traffic over the congestion-free Amazon Web Services global backbone, sending each user to the nearest healthy endpoint, an application load balancer, a network load balancer, an EC2 instance, or an elastic IP notice. What's missing from that description? Caching. Global Accelerator is built for non-cacheable, latency-sensitive workloads. The classic trigger words are gaming, Internet of Things, and Voice over IP. Here's the mental picture. If the public internet is a tangle of crowded city streets, stoplights, traffic, unpredictable detours, then Global Accelerator is the on-ramp to Amazon Web Services Private Express Highway. Your user enters at the nearest ramp, which is an edge location close to them, and from that point on the trip runs on Amazon Web Services fast, congestion-free backbone all the way to the region. It doesn't change the cargo at all, it just gives that cargo a much better road to travel on. The signature feature, the one that practically screams Global Accelerator on the exam, is those static IP addresses. Straight from the Global Accelerator FAQ, it provides two static Anycast IP version 4 addresses that serve as a fixed entry point to your applications, eliminating the complexity of managing specific IP addresses for different regions. So if a scenario says a client firewall needs to whitelist fixed, unchanging IP addresses, that's Global Accelerator. CloudFront does not give you static IPs, which means it simply can't satisfy that requirement. Let me hammer one point because it's the crux of the whole comparison. Global Accelerator does not cache anything. It improves the network path the traffic travels on, but it never stores a copy of your content at the edge. If the goal in a question is to cache static content, images, video, web pages, that is CloudFront's job, full stop. Global Accelerator optimizes the road. CloudFront stocks the corner store. Keep those two ideas separate and you'll never mix these services up. Here's the decision side by side. CloudFront works at layer 7 and caches. Reach for it with cacheable HTTP and HTTPS content, images, video, web pages, APIs. The trigger words are cache, CDN, and HTTP, and it serves content from the edge. Global Accelerator works at layer 4 and never caches. Reach for it with TCP or UDP traffic that can't be cached when you need those two static IPs to whitelist, and when you want fast, deterministic regional failover. Its trigger words are gaming, Internet of Things, and voice-over IP cacheable web content goes left, static IPs and raw protocols go right. Here's an angle people miss. These two aren't always either or. You can put CloudFront in front for caching and dynamic web delivery, and point its origin at a Global Accelerator endpoint to get that fast, deterministic path back to your regional application. The web tier gets edge caching, and the trip from the edge to your origin rides the Amazon Web Services backbone with static entry points. So when a scenario describes both heavy cacheable content and a strict need for static origin IPs or fast regional failover, the answer can be both services layered together, not one or the other. Here's the real difference in what each service does. CloudFront optimizes for cacheable web content at scale. It serves pages, images, and video from edge locations close to your users. Global Accelerator optimizes for deterministic routing of traffic that can't be cached, giving you static IPs and support for non-HTTP protocols. Now, both of these ride the Amazon Web Services global backbone, and both include free Shield standard DDoS protection, so those shared traits don't help you choose. The thing that actually decides it is your traffic type. Cacheable web content points to CloudFront. Non-cacheable traffic that needs static IPs points to Global Accelerator. Let's take a breath and recap the inbound side. Route 53 decides which endpoint a request reaches, using one of its 8 routing policies. CloudFront caches HTTP content at the edge so global users get it fast. Global Accelerator gives you static IPs and accelerates TCP and UDP traffic over the Amazon Web Services backbone without caching. That covers users reaching your workload. Now we flip to the second job, connecting the client's on-premises office into Amazon Web Services. There are 2 ways to bridge an on-premises network to Amazon Web Services. Direct Connect is a private, dedicated physical fiber link straight into Amazon Web Services, your own line, bypassing the internet entirely. Site-to-site VPN is an encrypted IPsec tunnel that runs over the public internet. Both connect a whole network or data center to your VPC, not just one laptop, and they trade off along the same axis every time. Direct Connect is dedicated and consistent but slow to build, while VPN is encrypted and instant but rides shared infrastructure. Hold that tension in mind. Picture 2 ways to make a phone call. Direct Connect is a private leased line dedicated entirely to you. The connection is crystal clear and steady. The bandwidth is reliable, but the phone company takes weeks to physically install it, and it's expensive. A site-to-site VPN is a scrambled call over the regular shared phone network. It's secure because the call is encrypted, and you can start talking today for very little money. But the quality depends on how busy that shared network happens to be. Dedicated and steady versus shared and instant. Here's the side-by-side. Direct Connect is private, dedicated fiber that bypasses the internet. Its big selling point is consistent, predictable latency. The cost is higher, and because real fiber has to be installed, provisioning takes weeks. And note this carefully, it is not encrypted by default. Site-to-site VPN is an encrypted IPsec tunnel over the public internet, so its latency varies with internet conditions. It's low cost, you can set it up in minutes, and it uses 2 tunnels for high availability. Notice the mirror image. Direct Connect trades cost and speed to build for consistency. VPN trades consistency for cost and instant setup. This phrase is where the consistent latency decision rule comes from. Amazon Web Services describes Direct Connect as a networking service that provides an alternative to using the internet to connect to Amazon Web Services, and the key clause, providing a more consistent network experience than internet-based connections. That phrase, more consistent network experience, is the entire reason Direct Connect wins whenever the requirement stresses predictable or consistent latency. Lock onto that wording. Direct Connect runs over a dedicated fiber line reserved entirely for you, so its latency is predictable and consistent. VPN runs over the shared public internet, so its latency rises and falls with internet congestion. That's a real engineering difference, not a preference. When your service level agreement demands predictable latency, say, for a real-time trading system or a critical healthcare integration, Direct Connect is the right tool, because a dedicated private line is the only way to promise steady latency. So the decision rule is simple. When the requirement is consistent or predictable latency, the answer is Direct Connect. But there's a wrinkle worth knowing. Direct Connect, by itself, is not encrypted in transit. So what happens when a scenario demands both consistent latency and encryption? Neither service alone satisfies both. The best practice answer is to combine them. You run an encrypted VPN over the Direct Connect link. That gives you the steady, predictable latency of dedicated fiber plus the encryption of the IPsec tunnel. So when you see both requirements in one scenario, the answer is Direct Connect plus VPN, not VPN on its own. Let's name the wrong answers that show up alongside these, because spotting them is half the battle. First, Client VPN connects individual remote users, one person's laptop, whereas site-to-site VPN connects a whole office or data center. So when the requirement is an entire site, Client VPN is the wrong choice. Second, Transit Gateway, which we covered last episode, is a network hub that connects VPCs together. It's not a method for reaching on-premises by itself. And third, remember CloudFront has no static IPs, so don't pick it when the requirement is fixed addresses to whitelist. Recognize these wrong answer shapes and you eliminate them on site. Let's pull it all together. Route 53 is Global DNS. Match the scenario keyword to the routing policy, whether that's weighted, latency, failover, or geolocation. CloudFront caches HTTP and HTTPS content at the edge, while Global Accelerator gives you static IPs and accelerates TCP and UDP over the backbone with no caching. Direct Connect is private fiber with consistent latency, but it's costly and slow to build. Site-to-site VPN is an encrypted tunnel over the internet, cheap and instant, but with variable latency. And when a question demands both consistent latency and encryption, the answer is Direct Connect plus VPN. Now let's see how well you absorbed all of this with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A multiplayer game uses UDP and cannot cache its traffic. It needs the lowest, most consistent latency to its game servers, and it requires 2 static IP addresses that players' firewalls can whitelist. Which service fits? Is it A, Amazon CloudFront, B, Amazon Web Services Global Accelerator, C, Route 53 Latency Routing, or D, Amazon Web Services Site-to-Site VPN? Lock in your answer before I give it away. This one is B, Global Accelerator. Every clue points to it: UDP traffic, non-cacheable, gaming, and the need for static IPs to whitelist. CloudFront only handles HTTP content and offers no static IPs, which rules it out immediately. Question 2. A bank's head office moves large, steady volumes of sensitive data to Amazon Web Services and requires the most consistent, predictable latency possible. Cost and provisioning time are secondary concerns. Which connectivity option should they choose? A. Site-to-site VPN, because it sets up in minutes. B. Client VPN, for the remote office users. C. Direct Connect, for a private dedicated link with consistent latency. Or D. CloudFront, to cache the data at the edge. Think about which constraint matters most here. The right call here is C. Direct Connect. The phrase most consistent and predictable latency is the tell. VPN is the tempting answer because it's fast and cheap to set up, but it rides the public internet, so its latency fluctuates. When consistency is the priority, it's always Direct Connect. Question 3. A company wants to test a new version of its website by sending exactly 10% of users to the new stack and 90% to the old one, then gradually shifting that split over time. Which Route 53 routing policy does this? A. Weighted routing. B. Geolocation routing. C. Failover routing. Or D. Latency routing. Got your pick? Let's see. The right call here is A. Weighted routing. Splitting traffic by percentage, 10% here, 90% there, is exactly what weighted routing is for. Anytime you see A/B testing or a gradual rollout where you control the proportions, that's weighted. Question 4. A global news site needs to deliver cached images and video to users worldwide with low latency, and it wants protection against SQL injection and DDoS attacks at the edge. Which combination is the best fit? A. Global Accelerator with 2 static IPs. B. Direct Connect with a VPN backup. C. Route 53 multi-value routing alone. Or D. CloudFront integrated with Amazon Web Services WAF and Amazon Web Services Shield. Pause here if you want more time. If you said D, well done. Cacheable images and video delivered over HTTP point straight to CloudFront, and its integration with WAF filters SQL injection, while Shield handles the DDoS protection, exactly the edge security the question asks for. Question 5. A workload runs in a single VPC, and a remote branch office needs an encrypted connection to it that can be stood up today at minimal cost. Consistent latency is not a concern. Which option is correct? A. Direct Connect. B. Site-to-site VPN. C. Transit Gateway. Or D. Client VPN. Run the decision rule from earlier before you answer. It has to be B. Site-to-site VPN. And here's why. Encrypted, low cost, quick to set up, and connecting a whole branch office to a VPC, that's the VPN profile exactly. Client VPN is for individual users, not a whole site, and Transit Gateway is a network hub, not a connectivity method to on-premises. Final word on edge and connectivity: Route 53, CloudFront, Global Accelerator, Direct Connect, VPN. Trust the decision rules, not your memory of vendor marketing. Subscribe for the next episode. See you then.